Good morning, students. I am Shukra Banerjee, Associate Professor of Department of Pharmaceutical Technology, Brainware University. Want to deliver a topic on general anesthetics, that is from medicinal chemistry, 402T, Unit 5. So, I want to share the slide. So, first of all, we should know what is general anesthetic. So, general anesthetic are drugs that produces loss of consciousness and therefore loss of all sensations. The absolute loss of sensation is termed as the anesthesia. Whenever there is needing any surgery or any operation, so then we need the anesthesia. The basic molecular targets show that the ligand-gated ion channels are a major target of anesthetic action. So that means where we have to give the drug, we should know where the drugs are active. They are working on the ligand-gated ion channels of the CNS or any cell of the body or where the particular surgery is happen to be on. So then the ligand-gated channels have to be inhibited or blocked. That's why the drug will be active. Next, general anesthesia is produces by producing sedation, loss of consciousness, and they produces different problem. And sometimes the loss of consciousness is sometimes cannot be reversed. That's why it is often preferable to use low concentration of the drug so that it is generally anesthetic problems are revived. Okay, so that's it. So, just going to discuss the general anesthetics. Many inhalational anesthetics such as barbiturate, benzodiazepine, propofol, that type of drug potentiate the action of inhibitory transmitter GABA to open chloride channels. So, there are some different channels or ion channels or receptors present in our cell. So, one of the GABA receptor, that is a gamma aminobutyric acid, is one of the receptor. So, that will be inhibiting the chloride channels. So as a result, the inhalation anesthesia will be producing. Okay. The action of glycine transmitter, which also activates chlorine channel in the spinal cord and medulla, is augmented by the barbiturate, propofol, and many other inhalation anesthetics. So some anesthetics are working on the spinal cord and medulla, and there are some chloride channels will be inhibiting this type of problem. So, sodium NO2, NO2O, and nitric oxide, nitrous oxide, ketamine selectively inhibit the excitatory N-methyl D-aspartate type of glutamate receptor. So, this type of receptor is also inhibited by the some of the drugs. So, these drugs are working differently. Next, types of general anesthesia. And see the slide. So, general anesthetics are classified into two categories: inhalation anesthetic and intravenous anesthetic. In case of inhalation anesthetic, gaseous and volatile liquids are used. So, in gaseous anesthetic, nitric oxide, nitrous oxide, ether, halogen, isoflurane, desflurane, and sevoflurane, this type of drugs are used. Next, intravenous anesthetic, fast acting, slower acting, these drugs are used. In case of slower acting, they are classified into three categories: benzodiazepine, analgesic, and dissociative anesthetics. So, in case of gas, nitrous oxide is used. In case of volatile liquid, ether, halogen, isoflurane, desflurane, sevoflurane, this type of drugs are used. In case of fast acting drugs, some injectables are used: thiopentol, beta, halogen, propofol, ethiodimate, like this. And slower acting benzodiazepine, these are drug working slowly: diazepam, lorazepam, and midazolam. Opioid analgesic, fentanyl, dissociative ketamine. These drugs are used. Now coming to the stages of anesthesia, the how drugs will be acting slowly. So there are four stages: stage 1, stage 2, stage 3, stage 4. In case of stage 1, that is stage is known as analgesia. Stage 2, excitement. Stage 3, surgical anesthesia. And stage 4, respiratory. So in the stage 1, muscle tone, the drugs will be characterized, or the anesthesia will be characterized by some physical characteristics like muscle tone and eye movement. So in case of analgesia, that is stage 1, muscle tones are very normal, breathing are very normal, and eye movements are slight. Okay? In case of excitement, normal to mildly increased. In case of some convulsion or seizure will be there, or contraction of the muscle will be there, and breathing will be somewhat disturbed, and eye movement will be moderate. In case of surgical anesthesia, when the deeper anesthesia is going on, slightly relaxed, muscle is relaxed, moderately relaxed, and markedly relaxed, and markedly relaxed. The movement of the muscles are relaxing slowly, slowly. And the breathing is also lowered as a result. The frequency of the breathing will be lowering slowly, slowly. And eye movement will be slight, and slowly, slowly, eye movement will be fixed. Eye pupil will not be moving continuously. Finally, respiratory paralysis, muscle tone is flaccid, that means deep anesthesia, and sometimes if concentration is high, sometimes to revive the anesthetic problem is somewhat different. In case of this respiratory paralysis, breathing is completely hurt and eye movement is not fixed. Next, going to the inhalation and anesthetic. Now we are going to deliberate the topic one by one. Inhalation and anesthetics are the drugs. So the inhaled gases are the core of anesthesia, primarily for the maintenance of anesthesia after administration of an intravenous process. Sometimes it has been found that if you introduce intravenous anesthetic agents, sometimes the anesthesia is taking time, a longer time to get anesthetic work. That's why some of gases or inhalation things are given. No one anesthetic is superior to another under all circumstances. The potency of the inhalated anesthesia is different as median or alveolar concentration. How can you calculate or rectify or optimize the inhalation anesthetics? By the MEC, that is a median alveolar concentration. How the alveoli of the lungs will be concentrated drugs, as a result the anesthesia will be produced. Coming to the halothane drug, that's a brand name fluothane, where triflu is there, used to start or maintain anesthesia. Sometimes it will be injected or will help the patient produce anesthesia, and it will be maintained for a short time. Benefits that it does not increase the production of saliva. Sometimes in case of anesthetic problem, some saliva secretion is there. It will not produce saliva. Side effects include an heartbeat, decrease in and problems. Now, halogen synthesis, trichloroethylene is reacted. Trichloroethylene, you can see the structure in presence of antimony trifluoride in the presence of 130 degrees centigrade, and then it produces 2-chloro 1,1,1 trifluoroethane, which in reaction with it produces halogen. This is one of the important reactions. Now coming to next drug, methoxyfluorine. In this case, all the drugs are containing fluoride that is used to reduce pain following trauma. Sometimes surgery is going on, then we have for the cutting or wounds will be there will be surgery, but there will be pain. That's why these drugs reduce the pain also. Also be used for the short episode of pain as a result of medical procedures. Onset of pain relief is rapid and short of duration. That means the pain sensation will be lost rapidly and short. Duration of action will be short. Use is only recommended with direct medical supervision because it needs some medical supervision to control this treatment. Now there are some side effects like methoxyfluorine. Common side effects include anxiety, headache, sleepiness, cough, nausea. Serious side effects like kidney problem, liver problem, blood pressure, and hypertension. Sometimes it happens. Okay, generally this type of common side effects. Now going to the next drug, enflurane. Enflurane is 2-chloro 1,1,2 trifluoride difluoride. See the structure, enflurane 2-chloro 1,1,2 trifluoroethyl CH2, this CH2, CH2, again diaphragm. Because CH3 or CH3 type of couple is where all the carbons, all the hydrogens are saturated or substituted with chlorine. It vaporizes readily, but it is a liquid at room temperature. Sevoflurane is another category, and the IUPAC name follows 111333 sulfurine. Sixth number of fluorine is there, okay? 2-fluoro-methoxypropane. So these all the drugs are propane because three carbon chains are there. It is sweet smelling, non-inflammable, highly fluorinated methyl isopropyl ether used as inhalation anesthetic for induction and maintenance of general anesthesia. After desflurane, it is the volatile anesthetic, fastest onset and onset. That means the drug produces action faster and the reviving of that anesthetic or consciousness is also fast. Next, isoflurane. Isoflurane is a general anesthetic. It can be used to start or maintain anesthesia. Often, another medication is used to start anesthesia due to airway infection. It is also general anesthetic and it is not particularly inhalational. There are some alphabet names 2-chloro, 2-difluoromethoxy, 111 trifluoro. Side effects of isoflurane like decreased ability to breathe, respiratory depression, low blood pressure, irregular heartbeat. Serious side effects may include malignant hypothermia, high blood pressure, like this. Next, we are going to categorize another drug. So, other different drugs are there, desflurane and ultra short acting barbiturates. These drugs produces faster action, like methoxyl sodium. This one category. Methoxyl sodium is injectable. It is a barbiturate category, which is classified short acting and has a rapid onset of action. It is similar in effects to sodium thiopental, a drug which is completed in short anesthesia. Methoxyl sodium synthesis you have to study. Now, thiomylyl sodium, that is one of the sedative anticonvulsant habits. Used strong as but short acting sedative. Used for induction surgical anesthesia. Can be used as anticonvulsant to counteract the side effects from the anesthetic. It is the thiobarbiturate analog of secobarbiturate. Thiopental sodium is an ultra-short barbiturate used commonly in the induction phase. Yes. Used commonly in the induction phase of general anesthesia, used has been largely replaced with the type of propofol. So, sometimes propofol drug is used. Now, coming to the dissociative anesthetics, that is one type of separate category. Dissociative, colloquially dissource, that's a subclass of hallucinogen which distort our perception of sight, sound, or sound, and produce feeling or detachment, dissociation from the environment of a cell. Although many kinds of drugs are capable of such action, dissociatives are such unique that do so in such a way that they produce hallucinogenic effects, which may induce dissociation, a general decrease in sensory experiences, hallucination, and dreamlike states and anesthesia. This is some sort of injector. Now coming to ketamine. Ketamine is a medication mainly used for the starting of anesthesia. Induces a trance-like state by providing pain, sedation, and memory loss. Other uses include chronic pain, sedation, severe depression. It is also a NMDA receptor antagonist, muscarinic receptor antagonist type. Some side effects are there like agitation, hallucination, okay, and elevated blood pressure, muscle tremor, related trouble. Spasm of the legs may some rarely occur. So synthesis that will be started class and discussed. Let's follow the slide. Okay. So thank you everyone for listening to the topic. You should study the chapters. Thank you very much.